here with the topic which is an important topic of class 10th, area related to circle. And before we start with this topic, thanks to all of you for liking my channel and subscribing it. Okay, so here in this topic, what we are going to do, we will find the length of the arc of the sector of a circle, we'll find the area of the sector of the circle, and we'll find the area of the segment of the circle. But before we all find all these values, we must know the content, we must know the topic. So here you can see we have a circle, and if we draw a chord, the area enclosed between the chord and the part of a circle, that is called the segment. So the smaller part, this is called minor segment, and the major part is called major segment. Likewise, if you take this circle, now what is a sector? Sector is the area enclosed between two radii and the arc of a circle. Now the minor portion, that is called minor sector, and the major portion is major sector. As far as this is concerned, in this diagram, so here how do we find length of an arc of a sector of angle theta? Now here you can see we have, this is a sector AOBP. This sector subtends angle theta with the center of the circle, and R is the radius of the circle. So here, how will we find the length of an arc of a sector of angle theta? Now, before I start with the derivation of the length of an arc of a sector of angle theta, let me tell you, as all of you know, the degree measure of a circle is 360, and length of the circle is, that is the perimeter I am talking about, this is 2 pi r. This is the circumference, or if we see the length of the circle, because we are finding the length of the arc of the sector of a circle which subtends angle theta with the center. Now here, how do we find the length of the arc of the sector which is subtending angle theta? Now if you see, for length of 2 pi r, here degree measure is 360, or if degree measure is 360, is 360, length of arc is 2 pi r. So similarly, degree measure is, if it is 1 degree, length of the arc will be 2 pi r upon 360. Now similarly, if the degree measure is theta, length of the arc will be 2 pi r upon, this will be 360 into theta. So here this becomes pi r theta upon 180 degree. So what is this? This is the length of arc of a sector whose angle is theta. So I must say, now this is the sector, and what have we calculated here? We have calculated the length of this arc. So well, after this I must say we'll come to the second topic, which is area of the sector of angle. Area of the sector whose angle is theta. So this is theta upon 360 into pi r square. So the same way we'll go, like if like area of a circle, here area of circle is pi r square, and if degree measure is 360, then area of the circle is pi r square. This is pi r square. So we'll continue with the same. If it is 1 degree, it is going to be pi r square upon 360, and here we have been given theta. If it is theta, it is going to be pi r square upon 360 into theta. So this is the formula for the degree measure of the sector of angle theta. This is pi r square theta upon 360. Now, well, the next thing which comes in the continuation, here you can see when we are talking of the area of the sector of a circle, we are talking of area of AOBP. We are talking of this. This is sector AOBP. That is, I am talking of this part. Now, if we have been asked to find the area of the segment, which you can see is the shaded portion, then how will we find? Like this is pi r square theta upon 360. So area of the segment APP will be area of the circle minus it's not circle, this is area of the sector, so I'll correct this, area of the sector minus area of triangle AOB. So as far as area of sector is concerned, we know what is the area. So we'll write pi r square theta upon 360, and as far as area of triangle AOB is concerned, this is what we will do. If it is r, the other radius, this is also r. So the formula to find is half r square sine of theta. You will be given angle theta, and then we'll put the value here in the formula to find the area of the triangle. Okay. Well, now I must say, student, we'll take few questions so that we can apply the formula in solving these questions. So I'll take, this is exercise 12.2, and let me tell you few questions so that we can understand about the topic. Now here, this is standard value of pi is given. Question number 1, 2 and 3. I would say you just try yourself because the question is direct. In first question we have been given the radius, we have been given angle, and he is saying area. Area of the sector, as I have already told you, the formula is pi r square theta upon 360. You have r, you have theta, just put the value here and then find the area. So this way you can find the question 1, 2 and 3. These are the direct question. I'll be taking question number 4. So in question number 4, as you can see, we have been given a chord of circle of radius 10 cm subtends a right angle at the center. Find the area of the corresponding minor segment and major segment and use pi is equal to 3.14. So here in this question, like I have made the diagram, the radii is given, this is a 10 cm and this is making an angle of 90 degree. We have to find the area of the minor sector and the area of the major sector. So first we'll categorize what is, this is minor and this is major. So area of the sector, we'll recall the formula. This is pi r square theta upon 360 and theta is equal to 90 degree. So this is pi r square 90 upon 360, that is 1 by 4, and this is 1 by 4 into 3.14 into 10 into 10. So we'll simplify this. So here this will get cancelled, this will get cancelled. So 3.14 into 25, we'll solve it and we'll get the value. So the value that we get is 78.50 square centimeter. Now here I must say the area of the sector which I have calculated, this is area of the minor sector. Now for area of the major sector we have two ways. Area of the major sector. This is area of the circle minus area of the minor sector. So what we can do, either what we will do, we'll find the area of the circle and then we'll subtract area of the minor sector, or other way around, we'll use this formula. And in case of major sector, the angle will be 360 minus 90, that is 270. So here formula will remain the same, pi r square theta upon 360. This is pi is 3.14, r is 10 into 10, theta is 270. So because theta we have calculated upon 360, so we'll simplify here. Sorry, only 1 0 will get cancelled. 9 3s are 9 4s are, so we have 3.14 into 300 upon 4. This is 75 into 3.14, and after multiplication we get the area of the major sector as 235.50 square centimeter. So here also you can see, but it has got two ways, like area of major segment can also, major sector can also be found by taking the difference of area of circle and area of minor sector. Okay. Afterwards, I want to take this next question, question number 5th, which says, in a circle of radius 21 centimeter, an arc subtends an angle of 60 degree at the center. Find the length of the arc, area of the sector formed by the arc, and area of the segment formed by the corresponding chord. So here we have to find three components. The first is we are finding the length of the arc, second is we are finding the area of the sector, and then we are finding the area of the segment formed by the corresponding arc. So here, whichever, the very first important thing in the question, we have to make the diagram. So I have already made the diagram. Now length of the arc, let us recall the formula. This is theta upon 180 into, this is pi r theta. So here r is 21 centimeter, and theta is 60 degree. We'll just put the value in the given question, 60 upon 180, and pi is already given to us. This is 3.14. So we'll put at 3.14, and r is 21. This will get cancelled. 6 3s are 18, 3 7s are 21. Now we'll multiply. This is 21.98 centimeter. Okay. Second step is to find the area of the sector formed by the arc, and then area of the we'll say area of the segment. Okay, area of the segment. So let us join this. First we'll find the area of the sector. Area of the sector. This is OAPB. The area is theta upon 360 into pi r square. Now theta is equal to 60, r is 21. We'll just put the value, 60 upon 360 into 22, not 22, this is 3.14 we can put. And but I must say the questions where we have the multiple as a, yeah, I was just referring to the book. Wherever we have the multiple of 7, we can take it as pi by 22 by 7. So I must say we can take 22 by 7, and r is 21 and this is 21. So 6 6 are 36, 7 3s are 21, 3 2s are, and this is 11. We'll multiply, which will give us 231 centimeter square. So here I must say in this question also, if you take the pi as 22 by 7, So we'll have different answers, slight difference in the answer. So it's going to be 22 centimeter. So I would suggest, whenever your radius is a multiple of 7, you take value of pi as 22/7, otherwise we'll take it 3.14. Okay, now third part is area of the segment. Now first of all, we must clear what is the area of the segment. Area of the segment. So here, this is the segment, and as I've told you, like area of the segment, APP, it will be area of the sector minus area of triangle AOB. Now your sector is OAPB. Now it is theta upon, that is theta upon 360 into pi r square. So 60 upon 360 into pi, that is 22/7, r square 21 into 21. And area of triangle AOB, I have told you, half r square sine theta. So we'll simplify this. Okay, this is 6 6 are 36, 7 3s are 21, 3 2 are 6, and this is 231 as we have solved earlier. No point solving again. Now r is here 21 into 21 sine 60. So this is 231 minus half 21 into 21. We can write 21 into 21 is 441, and sine 60 is √3/2. So here we can leave our solution up till this is 231 minus 441 √3/4. So I hope you must have understood how to find the length of the arc and area of the sector and area of the segment. And please go through the solution. If you have any problem, you can discuss with me, and I must say you give it a try how the solution goes. Thank you, and please like the video and do comment. Thank you and have a good day.